Hello guys, welcome to our channel AskPrep. Today's series is of 11th class chemistry. We will be studied about chapter 1, that is some basic concepts of chemistry in detail. Let's start the video. Start with what is matter. Anything which has mass and occupied space is called matter. At the macroscopic level, matter is classified into three main categories based on its physical state and properties: solids, liquids, and gases. Next topic is measurement. Measurement is the process of quantifying and assigning a numerical value to a particular attribute or characteristic of an object or phenomenon. It plays a crucial role in various fields such as science, engineering, economics, and everyday life. Measurement provides a standardized way to communicate information about quantities, enabling comparison, analysis, and prediction. Moving forward with SI units, the SI system, established by the General Conference on Weights and Measures, provides a standardized framework for measuring physical quantities. It includes 7 base units for fundamental scientific quantities, from which other units like speed, volume, and density can be derived. Next is mass and weight. Mass refers to the amount of substance present in an object. It remains constant regardless of the location. On the other hand, weight is the force exerted by gravity on an object. It can vary based on the gravitational field strength. The SI unit for mass is the kilogram, kg, while the SI derived unit for weight is the Newton, N. Next is volume. Volume is the measure of the three-dimensional space occupied by an object or substance. It's commonly quantified using SI-derived units, typically cubic meters. Next is density. Density represents the mass of a substance per unit volume. It is denoted by the symbol ρ, and its SI unit is kilograms per cubic meter. What is temperature? There are three common temperature scales: Celsius, Fahrenheit, and Kelvin. Celsius and Fahrenheit are related by the formula degrees Fahrenheit equals 9/5 times degrees Celsius plus 32, while Kelvin is related to Celsius by K equals degrees Celsius plus 2, 73.15. Next topic is law of chemical combination. These laws describe fundamental principles governing chemical combinations. Number one is law of conservation of mass. In a chemical reaction, the total mass of the reactants is equal to the total mass of the products. Antoine Lavoisier proposed this law in 1789. Second is law of constant definite proportions. The proportions of elements in a compound are fixed and constant. Joseph Proust formulated this law. Third is law of multiple proportions. When elements combine to form compounds, their masses combine in simple whole number ratios. This principle was introduced by Dalton in 1803. Fourth is law of reciprocal proportions. When two elements combine with a third element, their mass ratios are either the same or simple multiples of each other. Richter proposed this law in 1792. Fifth is Gay-Lussac's law of gaseous volumes. The volumes of gaseous reactants and products in a chemical reaction can be expressed as simple whole number ratios. Gay-Lussac formulated this law in 1808. Last one is Avogadro law. Equal volumes of gases at the same temperature and pressure contain the same number of molecules, proposed by Avogadro in 1811. Next topic is Dalton's atomic theory. In 1808, John Dalton published a new system of chemical philosophy, which outlined his atomic theory. 1. Matter consists of indivisible atoms. 2. All the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. 3. Compounds are formed when atoms of different elements combine in a fixed ratio. 4. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Next is atom. An atom is the smallest unit that retains the properties of an element and participates in chemical reactions, in non-radioactive reactions. Atomic mass is the mass of a single atom of an element, measured in atomic mass units, AMU, or unified mass, U. One atomic mass unit, AMU, is equal to 1/12 of the mass of one atom of carbon, 12, C12. Next is molar atomic mass. The mass of 6.022 times 10 to the 23rd atoms of an element, measured in grams, is known as the molar atomic mass. This quantity is numerically equal to the atomic mass measured in atomic mass units. When atomic mass is expressed in grams, it's referred to as the molar atomic mass. 6.022 times 10 to the 23rd power is known as Avogadro's number. This number of atoms, 6.022 times 10 to the 23rd, is also called 1 mole of atoms. A mole is a unit of measurement representing a specific number, just like a dozen represents 12 items and a million represents 10 to the power of 6 items. Molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by number of its atoms and adding them together. For example, molecular mass of methane, CH4, equals 12.011 U plus 4 times 1.008 U equals 16.043 U. Formula mass. Ionic compounds such as sodium chloride, potassium nitrate, sodium carbonate, etc. do not consist of molecules, i.e., single entities, but exist as ions closely packed together in a three-dimensional space as shown in figure. In such cases, the formula is used to calculate the formula mass instead of molecular mass. Thus, formula mass of NaCl equals atomic mass of sodium plus atomic mass of chlorine equals 23.0 U plus 35.5 U equals 58.5 U. Moving forward with mole concept, it is found that 1 gram atom of any element contains the same number of atoms and 1 gram molecule of any substance contains the same number of molecules. This number has been experimentally determined and found to be equal to 6.022137 times 10 to the 23rd. The value is generally called Avogadro's number or Avogadro's constant. It is usually represented by Na. Avogadro's number, Na, equals 6.022 times 10 to the 23rd. Percentage composition. One can check the purity of a given sample by analyzing this data. Let us understand by taking the example of water, H2O. Since water contains hydrogen and oxygen, the percentage composition of both these elements can be calculated as follows. Talking about empirical formula, the formula of the compound which gives the simplest whole number ratio of the atoms of various elements present in one molecule of the compound. For example, the formula of hydrogen peroxide is H2O2. In order to express its empirical formula, we have to take out a common factor 2. The simplest whole number ratio of the atoms is 1:1, and the empirical formula is HO. Similarly, the formula of glucose is C6H12O6. In order to get the simplest whole number of the atoms, common factor equals 6. The ratio is equals 1:2, 1. The empirical formula of glucose equals CH2O. Now moving forward with molecular formula, the formula of a compound which gives the actual ratio of the atoms of various elements present in one molecule of the compound. For example, molecular formula of hydrogen peroxide equals H2O2 and glucose equals C6H12O6. 1206, molecular formula equals N times empirical formula, where N is the common factor and also called multiplying factor. The value of N may be 1, 2, 3, 4, 5, 6, etc. In case N is 1, molecular formula of a compound equals empirical formula of the compound. Stoichiometry and stoichiometric calculations. See the image. Limiting reactant/reagent. Sometimes, in alchemical equation, the reactants present are not the amount as required according to the balanced equation. The number of products formed then depends upon the reactant which has reacted completely. This reactant which reacts completely in the reaction is called the limiting reactant or limiting reagent. The reactant which is not consumed completely in the reaction is called excess reactant. Reactions in solutions. When the reactions are carried out in solutions, the amount of substance present in its given volume can be expressed in any of the following ways. 1. Mass percent or weight percent, WW percent. 2. Mole fraction. 3. Molarity. 4. Molality. What is mass percent? It is obtained by using the following relation. Mole fraction, it is the ratio of number of moles of a particular component to the total number of moles of the solution. For a solution containing N2 moles of the solute dissolved in N1 moles of the solvent. Next is molarity. It is defined as the number of moles of solute in 1 liter of the solution, where M equals the number of moles of solute divided by the volume of solution in liters times 100. What is molality? It is defined as the number of moles of solute present in 1 kilogram of solvent. It is denoted by M molality, M. Number of moles of solute, mass of the solvent in kilograms. Some basics point to note. All substances contain matter which can exist in 3 states: solid, liquid, or gas. Matter can also be classified into elements, compounds, and mixtures. Element. An element contains particles of only one type, which may be atoms or molecules. Compounds are formed when atoms of 2 or more elements combine in a fixed ratio to each other. Mixtures. Many of the substances present around us are mixtures. Scientific notation. The measurement of quantities in chemistry are spread over a wide range of 10 to the power of negative 31 to 10 to the power of 23. Hence, a convenient system of expressing the number in scientific notation is used. Scientific figures. The uncertainty is taken care of by specifying the number of significant figures in which the observations are reported. Dimensional analysis. It helps to express the measured quantities in different systems of units. Thanks for watching video. We will be dropping notes in description of this video. If you found this video helpful, kindly do like, subscribe, and share. See you in next video again. All the best for your exams.